Hey everyone, how are you doing? Tim, how are you?
I'm doing well. Yeah, first, I was actually off last week, so
Yep.
hope everybody has been missing me. I'm not
Yep,
sure. You tell me.
I did. Good to have you back. Good to have you back. For all of you that are on the call, welcome to our Kubernetes masterclass. Today we're going to be looking at deployments at scale. We've got some interesting stuff lined up for you to do. We're going to be looking at cool models like GitOps. We're going to be looking at a GitOps tool like Fleet, which runs under the hood when you're making use of your Rancher server. But this is a really important aspect. And as usual, we're going to start off by dealing with the question why before we delve into things. But as usual, we like to give it a couple of minutes before we actually get started to allow for people to get settled. Because we started a few minutes late, we're not going to wait as long. So I'm just going to go quickly over some of the admin. If you haven't already seen, we've got a couple of active polls. So please do check out the polls that we have active at the moment. We'd love to get your feedback. It's a great way of bridging the gaps between us and you to understand your context a little bit better. So please do give some feedback to that. Also, if you've already got some questions, feel free to add them to the Ask a Question section in the bottom right corner. So as I mentioned, because we already delayed by a couple of minutes, I'm going to go ahead and get started. So give me a minute to share my slide deck. Awesome. So in front of you, you should see the main heading for this particular masterclass session. And as I mentioned, we're going to be looking at GitOps and Fleet multi-cluster continuous delivery with EKS, GKE, and AKS. That is a mouthful, but there is some exciting stuff lined up for you, and I think you're going to find it really valuable. Thanks a lot for tuning in. Welcome to all of you that have joined. And for those of you that are unaware, today is actually our last masterclass session for this particular Cloud Native at Scale series. So I certainly hope that you've been able to pick up a couple of things that have been very useful for your particular context. Remember that all the sessions are recorded and available to you here on Crowdcast, and some of them are available on our Rancher Labs YouTube channel. And head over to the Cloud Native at Scale playlist, and you'll be able to watch some of the previous ones as well. As usual, for this particular series, I am your instructor, and my name is Lukonde Mwila, or Luke, and I'm a senior technical evangelist over here at SUSE, and I'm a part of the SUSE and Rancher community team with Tim, who some of you have already seen, who is on the call with me, and we'd love for you to connect with us, so please feel free to do so, primarily in the SUSE and Rancher community network. And that is a great way for us to collaborate as well as work together on your learning journey and to learn from each other as well. And so you can feel free to reach out to me or Tim or our teammates as well. And in addition to that, you can also connect with us on LinkedIn or Twitter. There's a lot of awesome stuff going on in the community, and we would love to be able to help you and accelerate your learning journey in the cloud native space. So we usually start just with a little bit of Crowdcast admin, and this is especially useful for those of you who are brand new to these sessions. So real quick, if you have any questions, please feel free to ask them throughout the duration of the session. You can drop it in the Ask a Question section in the bottom right corner. If you notice that someone has already asked the question that you wanted to ask, you can go ahead and simply upvote it. If you notice that someone adds a question to the chat section in the right, please just encourage them to move it over to the Ask a Question section. Reason being, with all the feed going on in the chat, it's very easy to miss those questions, and we certainly want to try our best to address as many of them as possible. As I mentioned already, be on the lookout for polls. We want to hear from you, especially at this particular point in this series where we're drawing to the end of it. We want to get some feedback from you. You can also feel free to not only respond to the polls, but even in the chat, let us know what you found most valuable. If there's a particular session you found really useful, not only that, if there are things that were confusing or hard to understand, perhaps that's a conversation we can even carry over into the community, and we can continue to delve into something like that. And our most popular question has been whether or not the sessions are being recorded. And as I already said, absolutely, they are recorded and available to you on demand on this exact same link afterwards. So please feel free to check it out whenever is suitable for you. All right, so if you've missed the previous sessions, I certainly don't want you to be under the impression that you will somehow miss out on getting the most out of this particular one. They are designed to be standalone, but that being said, they do fit into a bigger picture. So this session fits into the picture of cloud native at scale, and we've been exploring the different dimensions of operating at scale. And some of those dimensions have included cluster management at scale, applications at scale, utilization at scale, and now we cap it off with deployments at scale. Each of those have had different resources, from Kubernetes masterclass sessions to technical articles that are available in the community for you to read. So if some of you have missed out on these and would love to get caught up, please feel free to reach out to me, Tim, Robert, or others in the community, and we'll be able to point you in the right direction. Okay, so what is lined up for you today? For starters, we're going to look at why continuous delivery is important in the context of Kubernetes. Some of you might be scratching your head a little bit because you understand that K8 operates at the infrastructure layer of the software stack, and you might not have been able to actually piece these together and perhaps just isolated it to an application context. So we'll be able to see why it is still important even in this particular domain. After that, we're going to look at why you'd be making use of multiple clusters in multiple clouds or multiple cloud providers, just so that we are able to marry the different things that we're going to be touching on today. And then we'll delve deeper into GitOps, its benefits, its challenges, and we're also going to take a look at Fleet, which is a GitOps tool that runs under the hood in Rancher, but can also be installed standalone. And then we're going to have a demo for a full workflow of CI/CD deployments to Kubernetes clusters, and we'll cap it off with Q&A like we usually do. All right, so that being said, we're going to go ahead and get started with looking at why continuous delivery is important in the context of Kubernetes. For some of you, this might be a no-brainer. For some of you, you might still be trying to figure this out. But in a nutshell, the same benefits apply. Continuous delivery is essentially the function of releasing changes into a specific software environment. Those changes could be brand new features, they could be refactors or bug fixes or experiments. And those different software environments could be dev, staging, or production. And this is especially useful and typically goes hand in hand with another concept known as continuous integration. And continuous integration is essentially the step or DevOps methodology in which you are trying to ensure that your software meets all of the qualitative criteria to make sure that any software that gets released or delivered is something that has been checked and meets all of the right boxes. So CI typically goes hand in hand with CI/CD. It is together, it is essentially the release of quality software. Now, we know that typically that does mean that you're not going to have completely if I could say completely clean software in your environments or 100% quality. Bugs and stuff will still kind of creep in, but the benefits of this particular approach is that it does reduce the number of bugs and also reduces the risks involved when it comes to the kind of software that you're putting out. And in addition to that, it drastically increases the rate at which your new features are rolled out, depending on the particular tools that you might be using. But this is one of the main things when it comes to CI/CD. It increases the number of releases rather that you are putting out into a specific software environment. Like I said, whether it's new features, bug fixes, or experiments. And going hand in hand with that, that also means that if any new software requirements crop up, you can essentially respond to those in a much faster rate, ensuring that you commit those changes to the relevant repository. It will go through the relevant test checks, and after that, be deployed to the appropriate environment. Now, that's more of in the application development realm, but those same benefits or principles essentially apply as well if you're going to make use of CD in the context of Kubernetes. And we'll be taking a closer look at how you can actually do that with GitOps. So even though it operates at an infrastructure layer, you can still get these exact same benefits with your Kubernetes infrastructure as well. So we've considered why continuous delivery is important in the context of Kubernetes. We need to look at another why question. These are really important because they pave the way for the particular solution that we're going to be looking at. And as you would have already noticed in this particular session, as was displayed in the main heading, we're going to be looking at essentially a multi-cluster model in multiple cloud providers. And the specific ones we're looking at are GKE, which runs in Google's cloud platform, AKS, which runs in Microsoft Azure, and EKS, which runs in Amazon's AWS cloud environment. And if you've got any experience in working with or managing cloud infrastructure across different cloud providers, then you're probably aware of the fact that there are some underlying differences. Now, granted, a virtual machine is still a virtual machine, but how you work with it in the different cloud providers can be a little bit tricky and challenging, and getting adept to the different integrations and the nuts and bolts and how these respective cloud contexts work. However, when it comes to Kubernetes, a lot of those risks and challenges are alleviated because Kubernetes by design is infrastructure agnostic, which is absolutely awesome because that kind of feeds into the next point that you'll see over there. This helps you achieve workload and workflow portability, because Kubernetes, for the most part, is essentially the same Kubernetes that you're going to get whether it's running in Google, in Azure, or AWS, or another cloud environment that you may be running with. And so even the very applications that are going to be running on Kubernetes by design are going to be will be able to work regardless of where you deploy them, and you don't necessarily need to make any changes unless you've made use of certain specific integrations with those cloud providers. In addition to that, this really helps when it comes to trying to achieve redundancy and availability of your applications. Some of you might be working at certain organizations where you want to make use of certain cloud providers in certain regions of the world, and so you are not hindered by the infrastructure layer or the application as well and having to make lots of tweaks. You can essentially still make use of the same platform and the same application in these different environments to meet those specific needs. And one of the main benefits with hosted clusters that draws a lot of people into using this particular approach is the fact that the cloud providers essentially take full ownership of the control plane and the data plane of your Kubernetes clusters. So that means they will be responsible for optimization, security, and high availability of these particular aspects of your Kubernetes clusters, which leaves you with the burden or responsibility of ensuring that the worker plane meets all the relevant requirements and is optimized. And that is a huge burden lifted, provided that that's something that meets your particular needs. And so lastly, just to cap it off with why teams or organizations might opt for making use of multiple clusters in multiple clouds is also because different cloud providers often offer certain tools that you could easily then integrate your Kubernetes cluster with, or the workloads with those cloud providers as well. And you might find that certain cloud providers may offer the same particular services. However, you can also kind of optimize your costs by opting for a certain one that works better. And granted that will start to introduce some of taking away from some of that agnosticism, but for the most part, you're still going to be dealing with the same K8s and the same K8s applications. So that workload and workflow portability really comes into play. And now, how does that come full circle with what we're going to be dealing with today? Well, this might actually be your model, or it could be a model that you put into practice down the line. And at the end of the day, you want to have the best possible way of actually deploying your applications to these different Kubernetes clusters in their respective cloud environments. Now, that being said, an optimal way of achieving continuous delivery in the context of Kubernetes is to make use of a model known as GitOps. Some of you might be familiar with GitOps, and some of you might be completely new to this term. In fact, I did look at the poll that I had put out, and I saw that some of you did mention that you're not making use of it, but you intend to, and some of you are not making use of it at all. And at this point, maybe there are a few that have also said they have no idea what it is. Well, you're in the right place. GitOps, as the name kind of implies, essentially brings together two worlds that you might already be familiar with. Git, which is your software's version source control, and Ops, which is taken from your operations or DevOps, and essentially brings these two methodologies together. And the reason why this is absolutely awesome is because when it comes to Kubernetes, which, as I mentioned already, is the infrastructure layer, GitOps essentially allows you to deliver or deploy on a continuous basis your infrastructure as well. So all those benefits that you get at the application CD, you can now make use of in the context of infrastructure as well. And so all of the declarations or definitions that you'd have for your Kubernetes resources, whether it's pure manifest files, if I could call them that, or Helm charts, those would essentially be stored in a Git repository, and that's where the Git comes in. And you would make use of what is known as a GitOps tool like Fleet, which is highlighted over there in that particular image. And that GitOps tool would essentially be observing both the repository as well as the downstream Kubernetes cluster. And the GitOps tool's responsibility is to make sure that whatever is declared in the Git repository is what is reflected or up to date in the downstream cluster. So the same way that Kubernetes works is what that GitOps tool is essentially doing. It makes sure that what you've declared in your Git repo is what is the declared and current or active state inside of your downstream Kubernetes cluster. But we're going to delve in a little bit deeper to see some of the main characteristics, as well as the benefits and the challenges, because I don't want to give you the impression that it is completely foolproof. After all, it is a relatively new model. So let's take a look at some of the characteristics, and you'll see how a lot of these actually tie to its benefits as well. For starters, infrastructure as code. And you might have already picked that up from some of the things that I've said. And IAC essentially presents a way of thinking or treating all of the aspects of your operations as software, including the hardware as well. So this is a universal principle for infrastructure as code. It is not exclusive to GitOps. So if some of you have worked with tools like Pulumi or Terraform as well, then that is essentially the same underlying principle or characteristic that you also get with GitOps, because all of the infrastructure of your Kubernetes cluster and its state is essentially defined inside of a specific Git repository. In addition to that, another main characteristic is immutable infrastructure. And so what this means is that once something has been instantiated, it should never change. It doesn't mean that your infrastructure never changes at all, but rather a specific instance of it. And so that means that when there's any new release or change to your specific infrastructure from a Git repository stance, then that will be a completely new version. And in the context of Fleet, that would be referred to as a bundle, a new version that then gets deployed. The reason why this is important is that it essentially protects you from configuration drift. So you have a specific instance of your infrastructure that gets deployed. So that is another main characteristic of GitOps. And then thirdly, and a lot of you might be familiar with this, is the declarative deployment model. Some of you might have worked a lot with bash scripts and all the different steps that you have to define for any particular application in order for you to get a certain desired outcome. A declarative model works different. That would be a procedural approach. In a declarative model, you essentially define or state what your desired outcome is, and a smart system that makes use of this particular model will essentially make sure that that desired state becomes the active state. And that's one of the main things with GitOps as well. As I mentioned when I was going through the definition of it, your GitOps tool will make sure that what has been declared inside of your Git repository is what gets reflected as the active state inside of your downstream cluster. If there are any differences, it will essentially reconcile those to make sure the current state matches the desired state. What are the benefits of making use of GitOps or GitOps strategy? And you might have already picked up on this. Well, similar to what you'd get with the benefits of infrastructure as code in Pulumi or Terraform or other IAC tools, is that it gives you a more reliable outcome. Once you've run it and you know that it breaks, for example, then you know that that particular instance is going to give you that same result all the time. Also, and the inverse of that would be when it is working right, you're essentially going to get that same outcome every single time. And that is extremely useful, especially because you can also version that. So it is very useful in the context of updates as well as rollbacks to specific stable versions for your infrastructure. In addition to that, it gives you a repeatable outcome. Once you've got things running for a particular dev environment per se, you could also just deploy that for another staging or production environment, and this is extremely useful. Can you imagine having to do some of the cluster configurations or optimizations for every one of your different environments in a manual approach? That can work, but you are a lot more prone to configuration drift, and IAC helps you solve that. In addition to that, it is self-documenting. Once you've got it declared once you've got your declarations inside of a specific Git repository, provided that someone understands how Helm charts work and and their anatomy, as well as Kubernetes manifest files. Well, just reading through those particular files will give them enough context and help them understand what is actually being deployed to the Kubernetes cluster. So that's really useful. And then something else that's really helpful in the context of GitOps is code reviews. So that's no longer something that's just exclusive to applications, but also in the context of your infrastructure. Now you can also implement quality gates, and you can have software teams essentially coming together to make sure that whatever is being deployed to your Kubernetes cluster in terms of the resources is something that meets the relevant criteria that has been agreed upon by that particular software team. And thirdly, because GitOps makes use of a declarative paradigm or model, that really simplifies the process of getting your desired state for your infrastructure. Instead, all you'd be doing now is writing those specific declarations, whether it's Helm charts or manifest files, and committing those to a repository, and your GitOps tool will essentially reconcile to make sure that the current state matches up with the desired state that has been defined in your Git repository. That's a lot better than you having to follow a procedural approach. So those are a lot of cool things, but if any of you are actually already making use of GitOps, then you might have run into a couple of issues. And some of them maybe aren't exactly the same problems that other people have run into. And so let's look at two main items that I recognize as actual challenges. And if some of you are making use of GitOps and you run into other issues, I'd love to see those responses in the chat as well, and maybe we can look at them later. But for starters, there's the collaboration requirement. And this one is a little bit of a weird one because it's actually a benefit. However, because of the change that GitOps introduces, it still presents a challenge to teams. Some software teams, or operators to be specific, might have been very used to actually just carrying out changes on an ad hoc basis. So GitOps actually requires a cultural shift within the team and supports a change by committee to infrastructure changes, which is time consuming for teams, and people might be preferring an approach where they could simply run a kubectl or kubectl command, but now that responsibility has essentially been offloaded to a GitOps tool. And so sometimes this can cause a little bit of tripping within a team, but in the long run, it is for the better. In addition to that, because it is a novel approach, there aren't really any universal practices. You can understand how GitOps works and you can apply it in that particular way. But as you work with your specific requirements, you might start to find that there's certain things that are hard to implement, and you're having to make certain tweaks for your specific context that wouldn't necessarily translate or apply to another software team. And so if some of you have already identified some things that you think are universal best practices outside of the main concept of GitOps, I'd love for you to share those as well. But these are some things to be aware of in the case that you actually want to start making use of a GitOps strategy for your Kubernetes clusters. Now that we have considered what GitOps actually is, its benefits and its challenges, I did mention making use of a GitOps tool. And your GitOps tool is a big part of this entire process because it is essentially the engine that is reconciling what is stored in your Git repository and updating the state in your downstream clusters. And in the context of Rancher, we have Fleet. Now, Fleet is an open source tool that you can actually make use of standalone. And that means you can install it by itself on a Kubernetes cluster. And there are two main approaches that you could take. You could actually have Fleet running on a Kubernetes cluster where it will be managing deployments to that same cluster to perhaps, let's say, different namespaces if that's where your workloads are running. On the other hand, if you find that you're going to be making use of multiple Kubernetes clusters, then it is best to make use of Fleet running as a standalone server or manager in its own Kubernetes cluster, managing the different downstream clusters. And it essentially will be watching different Git repositories that you define or a single Git repository, and it will then carry out the same processes that I already mentioned. Now, the cool thing about making use of Fleet with Rancher is you get all the other benefits that we have touched on in previous weeks when it comes to multi-cluster management. Continuous delivery in the context of Kubernetes is just solving one problem. And if it happens that that is all that you need, then you can certainly install Fleet as a standalone solution. However, if you find that you need to address all the other issues or pain points when it comes to multi-cluster management, I strongly encourage you to make use of Fleet with Rancher, in which case you won't need to install it. It comes out of the box. You simply need to head over to the continuous delivery section, and we'll be taking a look at that a little bit later. Now, it is often very useful to understand how Fleet actually works under the hood. And that would be the case with any GitOps tool that you're making use of. And so let's look at some of the core components so that you understand how it's actually doing its job. And you might see some similarities with Fleet and Rancher's architecture as well. For starters, we have the Fleet Manager. And this is the central component that essentially governs all of the deployments of the KH resources from your Git repository to your downstream clusters. And in addition to that, we have a Fleet controller. And the Fleet controller runs on the same Kubernetes server or instance where your Fleet Manager is running, and it will perform all the GitOps actions. So if you're familiar with how the Rancher architecture works, you might be considering the cluster controller as well, and how there's one designated to each downstream cluster, and it essentially does the heavy lifting when it comes to ensuring that the declared state is what actually gets updated or reflected as the active state inside of the downstream cluster. So the Fleet controller takes a very similar responsibility. And on your downstream clusters, you have a component known as the Fleet agent. And the Fleet agent, very similar to the cluster agent in the context of Rancher, communicates with the Fleet Manager through the Fleet controller in order to make sure that all of those actions are actually operated, as well as so that the Fleet controller will have context and understanding active state versus desired state. Another core component is the Git repo Kubernetes object, and this is a custom resource definition. And this is essentially a resource that you'd have that would be watching, that Fleet essentially takes note of for any changes inside of a specific Git repository that is being watched. And in the case that there are differences or updates, then Fleet will essentially recognize those changes and compare that to what is actually active in the downstream cluster, reconcile those changes before carrying out a deployment or an update. All right, so now that we've covered the theory, which is super important, the next thing we're going to do is actually have a look at a full CI/CD workflow, and I'm going to be showing you how to actually make use of Fleet in the context of Rancher. But in doing that, I wanted to show you the full life cycle, starting from an application with its change to a specific application, it getting containerized, a CI flow, and then capping it off with the CD flow. So there might be a little bit of switching of screens, but do bear with me as we cover the different components. And the first step will be to come on over here to my editor, and you should be seeing Visual Studio Code. And I think the best thing, just to reduce confusion, will be to get rid of all those other things and to collapse this over here. And I'll start off with just walking you through the structure of this particular project. Now, for starters, we have the application folder, which is where our application actually lives, along with the relevant Docker file. And then we've got another folder over here called IAC, and that's just all the source code, Terraform source code to be specific, for provisioning the CI pipeline and build inside of the AWS environment. We're not going to be going over that because that's its own particular topic. And then we also have K8 manifests, and this is where we want the output of our Kubernetes manifests to live once the relevant changes have been undergone. And then we have customizations over here where our customized configuration files actually live. So I'm making use of customize to update and produce my K8 manifest files. Now, I want to note over here that if you're going to follow a similar model in your particular context, I'd encourage you to have your K8 manifests in a separate repository, because if you're going to have a polling action for your CI stage, well, that essentially means anytime that a change is recognized to this particular repository, that will trigger the pipeline and the CI build. Now, if you find that at the end of that CI stage, what you're actually doing is updating the relevant manifest files, and it's inside of this exact same repository, you kind of end up with a loop, and the pipeline will then essentially be starting and probably failing because of certain changes that you make. So just make sure that if you're going to follow something similar, you have K8's manifests living in a separate repository, but for demonstrative purposes, this will still work. So I'm going to be careful to not delve too much into things that aren't entirely related to what we're talking about, but I do want you to have enough visibility to get a good understanding of what we're going to be touching on over here. So this is a basic Node.js application. Some of you might be very familiar with the usual example that I make use of, and all that is taking place in here essentially is I'm making use of the Express framework, and I have a single root, which is test, and it gives the response simple node app working version 1.0.4. So when my application has been deployed, that is the outcome that I actually want to have. Now, as I mentioned, as part of the CI stage, you want to make sure that you have a quality gate and ensure that your application meets a certain criteria. So you should actually be running automated tests. That's a big part of what CI is actually meant to serve as. And so in here, not to worry if you don't entirely understand how JavaScript works, that's totally fine. All I want you to have visibility over is the fact that I am running a specific test that's going to test that specific route that I have to make sure that I'm getting the right response in whenever that is queried. So I should get a 200 response whenever that specific endpoint is queried. In addition to that, the response should be a text string that matches this value over here, because that's what I have defined inside of my application. And you'll notice over here that I have a Docker file. And this is essentially me just containerizing my application, because that's exactly what we're going to be deploying to our Kubernetes cluster. We're deploying a specific container. And so here I'm following the usual steps when it comes to containerizing your application, starting off with creating the image, making sure that I have a specific base image specified. And so I'm making use of node 14 Alpine. I define the specific working directory that I want to have for this particular image. In addition to that, I copy over the main package.json file, because that's where all the dependencies for this application are specified. And then I run the npm install command, which is just going to install all the relevant dependencies for the application. It'll then copy over the source code. And then I'm running the expose 8080 command so that Docker is aware of the specific port that my application is listening for traffic on. I modify the ownership permissions to be specific for the user node. And then lastly, just running npm start for this application to get started. So that's one of the main things to understand. The next thing, before we actually look at the build steps, which will also be important, is to understand how the customizations are actually working. Now, Customize is an excellent tool for actually modifying and updating or manipulating your Kubernetes manifest files. And so what I have is my base customization file. And you'll notice over here, let me also open this deployment.yaml file, that inside of my customized file, I'm essentially defining what the main resource is as my base, which is this deployment.yaml file. And then I specify the details, or the properties rather, that I actually want to change when I'm outputting a new deployment.yaml file. And so I specify the name of the image, and you'll see over here that there's new name and new tag. And these are the values that are going to be modified inside of my overlay. And the cool thing about overlays is it allows you to essentially apply that for different environments. In my case, I'm simply working with a dev environment. Now, just so that you can see that the deployment manifest file, it is a very basic deployment YAML file. If you're familiar with how these work, then there's nothing really to it. I specify or define the main things that I typically would have. Now, because this is my base one, you'll notice that under image in the spec section where we have our container configuration, I have not specified any particular version tag. Now, this would automatically then trigger a pull of the latest version, in which case we would then have the latest version that has been deployed to that specific repository, and I'm working with Docker Hub. Now, this is not a good practice because you want to be able to specify a specific version. Also, this will easily trigger the continuous pulling of those images. So you want to make sure you're specifying a specific version as well based on the changes that you would have made to your application. And so all of this is a process that I'll be automating. And so inside of my overlay over here, as you'll see that I'm pointing to the base, which is this folder with those specific files that I just showed you, which has the deployment and the base customization. And essentially what's going to take place is during the CI stage, I am going, based on the new version build that will be coming out, I'm going to modify this particular tag to the new version coming out. And to modify my customization.yaml file, I'm just going to be making use of a tool known as YQ. So that will happen inside the CI stage. And so once YQ has updated this new tag in this overlay file, I can then run the relevant customize command for this specific overlay, which will then produce a new deployment manifest file. And I can then choose where that deployment manifest file should be uploaded to. In my case, it's going to be in this same repository, which will then be, of which those changes will then be committed to the relevant remote repo, and our CI stage essentially kicks in. Now, I understand that there are a number of steps here that some of you might not be familiar with, but like I said, I think there's a lot of value in getting the full picture of how this process would work in an automated way, and we'll kick it off shortly. So over here, I have a build configuration file for code build, which is a specific CI tool, and not to worry if you're not familiar with it, because a lot of these concepts would essentially be the same in a different CI tool as well, and I just want you to pay more attention to the story than the specific commands themselves. And so in the pre-build stage, I essentially start off with installing Customize because I'm going to be making use of that. I install YQ because I'll be making use of that as well. And there's some AWS-specific tooling that I'll need as well, which is why I'm importing those. But as I mentioned, you don't need to worry too much about that. And then very important is the dependencies for the specific application, which is where I'm running the npm install command over there. And the reason I'm doing this, even though I'm essentially producing a container in the end, is because I want to start off by testing my application. So you'll see over here in the build commands, maybe let me just zoom in a little bit more. You'll see over there, I just run a few echo commands just so I'm aware of what's happening and when. And the next thing I do is I run npm run test, and this will essentially run that same test that was inside of that Node.js application over there. And once that test has been run, and provided that it passes, then the CI steps will continue, or the build steps to be specific. In the case that it fails, then all of this kind of falls apart. But if it does pass, then the next thing that I want to do is essentially read the version for this particular application that I want to put out, and I store that inside of an environment variable called container image tag. So once I know that my application meets the quality criteria based on that particular test, the next thing to do is to build the Docker image. And so I do that the same way that you would even on your local machine. Just I tag it with the specific container image tag that has been pulled from the package.json file. Once I've done that, the next thing is to push this to Docker Hub. And so I will need my Docker credentials. And as you can see over here, I'm making use of environment variables to mask my Docker ID and my Docker password. I log into my Docker Hub account. And then during the post-build stage, I proceed to push this Docker image that I just built in the previous section. And so the cool thing now is at this point, we have a new image stored inside our Docker Hub repository. However, that doesn't necessarily mean that our application will magically update. And the reason for that is because our Kubernetes manifest files or resources have still got the same previous image tag. So what we need to do now is have that be updated. And so the approach that I'm taking is to essentially clone the repository, this exact same Git repository inside the CI stage or inside the container where this is running. And inside of that, as a part of that same process, I cd into that same folder for that Git repo, and you'll notice I'm cding into customizations. So what's taking place is inside the CI stage, I'm essentially cloning this entire application project, and then I cd into customizations. And if you recall what I mentioned, is that in the overlay customized file, I need to update the version. And I'm going to open this just to make it easier to understand, because I know there are a lot of different pieces in this. And so this has to be updated with the new version that would have just been bumped up inside of the CI stage. And so once I've done that, you can see over here, I'm running the same command, container image tag, and I'm getting that version from the package.json file. And after that, I then run the customize command, and you'll see I'm running customize build overlays dev. So customize is going to build a deployment manifest file for me based on this new version tag. And because it's pointing to the base, it will essentially get everything from that base file and update with the relevant overlays specified for dev. And this is really cool with overlays because it gives you those results for a specific environment. Because as you would understand, or most of you would understand, when it comes to the software development lifecycle, you probably want to test a specific version in dev before deploying it to staging and, of course, ending off with production. So once that's done, we've now got a new deployment manifest file that gets exported to K8's manifest, as you can see over here. So I'm going to collapse this application folder and collapse customizations because we're done with that. And so essentially, we end up with a new deployments manifest file inside K8's manifests. And this is the specific file that is being watched by our GitOps tool. However, at this point in the CI stage, it's still local. And so what we need to do at this point is to commit these changes and push them to that repository. So you basically go through the same Git commands that you would when you're working with any repository, even in your local context. And so that's what I do over here. I essentially run the relevant Git commands, commit it, and then push those changes to the develop branch, because this is for the dev environment. And once I've done that, my GitOps tool will then notice that change and proceed to deploy that to the relevant downstream cluster. So what I'm going to do here for demonstrative purposes is I'm going to come to application, and I'm going to head over to the app.js file. And because I want to bump the version to version 5, I'm going to modify that file. Close this. And in addition to that, I have to update the test. Otherwise, this is going to fail in the CI stage. Change that to simple node app working, version 1.0.5 as well inside of the test, as you can see. And if you recall, we're actually typically getting our version from package.json file. So inside of our Node.js application, this is where we modify that as well, because this is where you actually control the version for that particular application. The rest is just so we can actually have some visualization of those changes. So at this point, once that's done, the next thing that you need to do is just to actually commit these changes. And I've actually noticed something that is incorrect in this. So I will quickly switch to the browser. And I see my repo over here. I'm going to just get that. Switch back to the editor. And I am going to copy this part. So I'm going to get that. And copy that here. So that was just an error that I picked up. So the next thing to do is I'm going to head over to my terminal. I run Git Status. I have a couple of changes. So if you start thinking or visualizing the particular workflow that you'd typically be going through, now your software developers would then just go through the normal steps. You can say git add, git commit. And I'm just going to add feature. And I will say version 1.0.5 released. And I'm going to then proceed to push those changes. As you can see over there, the next thing is switch over to my browser. And I'm going to just confirm that those changes have been made. And you can see about 18 seconds ago for the application, there have been no other changes to the other parts, because every other step for the K8s manifests and the customizations has to be automated. So the next thing would be to check out my pipeline. And as you can see, it has already triggered. So you can see just now, this is the source for the specific GitHub repository. If I click I, you'll be able to see that CI for GitOps pipeline. The branch is developed for my specific file. And so now it's going through the build stage. And so we're going to leave that running. In the meantime, the next thing that we're going to do, I'm going to come over to my Rancher server. And I'm going to head over to continuous delivery. So if you want to make use of fleets inside of Rancher, you'd head over to continuous delivery. And this is where you would create your Git repo. So I'm going to click create. And I'm going to call this node application for the Git repo. And then next thing is to specify the specific repository URL. So I'm just going to grab that from here. And paste that there. And I want to watch a specific branch. In this case, I'm watching the develop branch. So I'm going to provide that here. And there's no Git authentication because this particular repo is a public repo, as you can see over there. So I'm going to leave the TLS certification validation as is, and then I'm going to add a path. The reason I'm doing that is because, remember, I want my Git repo to be watching specific manifest files. And so in the context of my repository, the output goes to the K8s manifests. So this is the directory that Fleet should essentially be watching. So you could just do this. In my case, it's K8s manifests. Make sure you get the spelling right. You could easily get tripped up on that. And then lastly, you can choose where you want that to be deployed to. If you leave it as is, it will target all of the clusters in the workspace. In my case, I am going to start off with specifying one cluster, the alpha cluster, and then I'm going to hit create. And as you can see, that has now created a Git repository resource inside of Rancher. And I'm just going to click on it and give it a bit of time for it to do its job. The main thing that we want to eventually see will be for this pipeline to succeed. And after that, to see if those changes being watched by Fleet will then be essentially deployed or delivered to our downstream cluster. So at this point, I'm actually going to stop sharing because this is going to take a couple of minutes. And then the next thing that next we'll be able to address a couple of questions and get started with that. And I'll keep checking in with what's happening over here. All right. So Tim, if you're still on the call, you could perhaps join me on screen and we could work through some of the questions together, especially as I keep an eye on things that are running.
Yes, I am still here.
Great.
All right. There is quite a bit of stuff going on here in the questions. So let's see. Maybe a couple of rather housekeeping related things that we can get out of the way quickly.
Sure.
You do have the repository with the code that you've been working with available, right?
That's correct.
Somewhere.
Yeah.
And I think Simon probably already found it. It's in your personal GitHub, right?
Yes, that's correct.
All right. I'll just pick it up from here and paste it in chat so that.
Great. And I see Simon also shared it.
Ah, awesome. Didn't see that. Okay. So I'll mark this one answered. So we had someone ask, can you go again over Fleet Manager versus Fleet Controller? What are the functions of the two and what's the difference between them?
Sure, great question. One of the reasons I kept tying it back to the Rancher architecture is because they work very similar. So your Fleet Manager is like the central component that is governing everything. So think of it also as equivalent to your Rancher API server as well. So it's what's governing all of the deployments of the K8 resources from the Git repository. Think of it somewhat as an orchestrator. So that's what your Fleet Manager or Fleet server is. The controller is a specific component that runs on the same Kubernetes cluster as the Fleet Manager. However, whereas the Fleet Manager is responsible for watching everything that's going on and orchestrating everything going on, your Fleet Controller has a dedicated job for a specific downstream cluster, very similar to the Rancher controller component as well. Excuse me. And it essentially communicates with the Fleet Manager and also helps with maintaining state on the downstream cluster. And I'll just go over the Fleet agent again, just so that helps. And remember, the Fleet controller is communicating with another component on the downstream cluster known as the Fleet agent. So you got Fleet Manager communicating with Fleet controller, communicating with Fleet agent, and the communication goes all the way back up as well. So I hope that helps provide a little bit of clarity. If not, just let me know if there's any additional thing to just to help reconcile over there.
All right, thank you very much. There is an interesting question from Philippe. So he's basically saying this is a best practice example of GitOps, but one could forget about customize and overlays and do a simple hello world deploy Kubernetes manifest that is manual full text, and this would be deployed by Fleet as well, right? So I guess the question is, can I just take a regular application manifest and have Fleet deploy that one? Like, Philippe, if I'm not getting your question correctly, please let us know. But let's try it.
Sure, great question, Philippe. Absolutely. You could essentially remove a number of the things that I added in this particular demonstration. I was going for an example that could help you kind of have the closest real world feel to it. But you could essentially just have a Git repository and your GitOps tool watching that as well. You could get rid of customize and all the other things, and you just have a basic, for example, even a pod.yaml file. And as long as your GitOps tool is configured to watch that specific repository, it will still do the same job of reconciling to make sure that what is the current state in the downstream cluster matches the desired state in the Git repository. I would actually encourage you, that's the best way to start. You don't want to jump right into the deep end. Best to familiarize yourself with how this works in a very simple context before making your way to more complex things.
Yeah. Plus, what I want to add on top of that is it is possible to tell the repository resource that you deploy to also watch only subparts of a repository. For example, a particular directory or even a particular YAML file. So you don't have to basically set it up so that it deploys everything that is in a repository.
Right.
All right. So let's see, what else do we have? Okay, so this one is good. This one's a good one from Al Hussein. Is there a dedicated course to GitOps with Rancher Fleet? I can see it will be covered in the week 7 of Up and Running with Rancher, but if there's anything more, that would be great. Luke, what's your take on that?
Yeah, that's a really good question, Al Hussein. So we don't have a dedicated course for GitOps with Rancher Fleet. However, we do have a lot of other good resources in the SUSE and Rancher community. In addition to that, in fact, I would start off by saying, have a look at a previous course that Tim actually run. And in that course, Tim actually dives into a GitOps section. So you'll be able to get a lot of meat in that particular one. I think, Tim, you dedicated more than one session in that one, if I remember. Or was it also in a standalone session?
I think you're referring to the Accelerate Development Workflows class, right? So that one will run again in December. So I think the announcement will come out soon. So, and I do have a session on, CI/CD more generally, and then another one on GitOps as well. So stay tuned for the announcement of that class, which is going to come out momentarily, and we'll talk a little bit more about Fleet in that one as well. But I would also like to say that if you have specific questions, or if there's something you're looking to do that hasn't been answered by the materials that you've seen so far, just let us know. We will be more than happy to look into that and see if we can help. And maybe we'll be getting a couple of good content ideas that way as well. So we're always on the lookout for things that matter to people. So tell us what matters to you, and we'll do our best to help you out. All right. So, this is a good one as well. So what's the relation between Rancher Fleet and KubeStack? Any take on that? I must admit that I haven't been aware of KubeStack before I saw this question. So, but in case you know it, maybe you can say something about it.
Yeah, no, similar to you, Tim. Joseph, I'm actually not familiar with KubeStack. I see Simon has shared a resource over there, so I hope that can be helpful to you, Joseph. But yeah, I don't want to lie to you.
Yeah, all right. So what I was able to tell from a quick glance is that KubeStack is Terraform based. So the way you define your GitOps flow is, as far as I understood it, in Terraform versus Kubernetes YAML in case of Fleet, or of course you can configure things via the Rancher UI. So I guess that would be the most obvious difference. But other than that, I guess we would have to dive in a little bit more to dig out the more subtle differences. All right. We have a question from Hayden here. Fleet also supports Helm for CD. What are the advantages of Kustomize in this scenario, I guess?
Yeah, very good question, Hayden. So Kustomize is helpful also in the context of using Helm, just to tie those two things together. But Kustomize basically is a good tool for manipulating or modifying your Kubernetes resources. So there are other tools out there that you could use, but Kustomize is essentially one of the main go-tos, if not the main go-to for changing YAML configuration files in a clean way. So if you noticed, one of the things that I mentioned and as well as demonstrated was the overlays feature. So you'll find that you want to have an optimal way of actually having some base files and then making changes to those base files for specific environments. And that's just one of the main uses. And so like you saw that I was showing for a dev environment, for example, you could then spit that out with the relevant changes for that particular one as well. And you could bring Helm into the mix as well. In the case that you're working with a Helm repository, remember that your Helm repo would still start off with essentially having those Kubernetes resources. So if your pipeline happens to consist of packaging the Helm chart as well and then updating a particular repo, Kustomize would still fit into that particular context. It's just that in my example, I was deploying with straight up Kubernetes manifest files.
All right. Okay, I would suggest we take one more unless something else comes in, but I think this one is too interesting to skip over it. So
Okay.
from Ahmad, we have the question, is there a customization to Fleet to give alerts if a change fails in the CI/CD pipeline?
Right. Sorry, Tim. Could you just reread that for me?
Yeah, sure. So if a CI job gets triggered the way you did it in your example, but for some reason the tests aren't passing and the actual deployment eventually doesn't happen, is there a way to set things up so that I get alerted about that? Because I mean,
very good question.
I obviously will want to know, right? I mean, I can do this. I would know how to do this with GitHub Actions, but that's obviously not what we want to do with Fleet, right? So how would that work?
That's a very good question. So if you recall what I mentioned about what Fleet job is, or a GitOps tools job is that it is essentially watching the Git repository. And that is what it's using as its single source of truth for desired state. Anytime there's a change there, it will then compare that to the current state in a downstream cluster and then reconcile based on that. If there are no changes to that particular Git repository that Fleet is watching, then Fleet is essentially just going to be checking in every now and then to make sure that there aren't any changes. So that is actually separate from the CI stage, which you're actually asking about, in which case, regardless of the CI stage that you're going to be, a tool rather, I should be specific, that you're using, whether it's GitHub Actions or Circle CI or Jenkins, you could essentially configure that CI stage to then send some kind of trigger or alert, whether it's via email or Slack or something, to notify you that a build failed. And I'd be happy to share some other resources with you on how to configure something like that. But I hope you can see that it's somewhat of a different world or a separate part. That's dealing with the CI stage and alerts around that. And then you've got the CD stage with Fleet. Tim, I'm not sure if you want to add anything to that.
Well, I mean, I think that's exactly what I would have said as well. The only small remaining bit in this equation is if something gets deployed to the Git repository or branch or resource that Fleet is watching, and for some reason the deployment that Fleet then tries to do to the downstream cluster doesn't work, that would essentially be an error that gets caught in the Fleet custom resources somewhere, right? So where would we see something like that?
Right. So if you want specifically to see on the Fleet side of things, you can have a look at the Fleet agent. That would be a good one to start with, because remember, that's a specific component that is running on the downstream cluster. So you want to check to see what the errors are over there. In addition to that, another good one is the Git repo. So you might be running into some issues. I'm going to touch on some different errors here as well, because remember, your Git repo is a custom resource definition as well that's watching a specific repository. So this one might be one of the first errors that someone could potentially run into in the case that you have a private repository and you haven't correctly configured the relevant security or rather authentication to put in place, in which case have a look at the logs for that Git repo custom resource definition, and it would then tell you if it's failing, because that's essentially the first step. If you can't get your Git repo working right, then you're not going to have anything deployed. So I would actually, say, have a look at that, the Git repo and the Fleet cluster agent as well. If things have already started working, then you run into an error. Start with the Fleet agent because you know that you've already had previous releases. But if you can't even get things up and running for starters, then I would say go a step back and have a look at the Git repo logs.
Yeah, and that would be basically a kubectl describe on the resource, or even getting the logs from the respective pods, right?
Absolutely, that's correct. Yeah.
Okay. Awesome. So let's see. Oh, we had one, maybe two more questions that coming in that I don't want to miss out on.
Sure.
So one more from Hayden. Is it best practice to isolate application and manifest or Helm charts in separate repositories?
Very good question, Hayden. I like that.
We're hearing often.
Yeah, is it best practice to isolate application and manifest or Helm chart in separate repos? Hayden, I would actually say this is more in this in the realm of mono repos versus multiple repos. And I love mono repos, and I know that they're very popular. However, I think that sometimes one of the things that people overlook is that you need some really good tooling in place to make use of a mono repo, because you're storing all of the different aspects of your architecture in a single repository. And what you find ends up happening if you're going to go with a mono repo is, for example, in my case, is now you kind of have to start doing some gymnastics with your code to make sure when you update this, don't affect that, or only touch this and don't deal with that. So those kinds of little quirky things, and that might work with a very basic application, but with a large application, I think it's really good practice to separate things. And so, like I mentioned when I was doing that walkthrough, I really think it's best to have your manifest or Helm charts in their own repository. Have the application or microservices living by themselves. And as part of your CI stage, when those changes have been made to the application, push the relevant changes to the repo that has the manifest files or the Helm charts.
Yeah, I would definitely second that. So if in doubt, keep it separate. That's that's the rule I provide. That's the rule I go by. I actually haven't run into a scenario myself where I ended up putting both into the same repository for particular reasons. There's a certain amount of pain involved with having everything in the same repository, and I think I'm not aware of a good practice or a scenario where that makes more sense than keeping things separate. Like you have an individual version history, you can do individual numbering schemes, or manage your releases for your deployment manifest separately. So yeah, that's what I would default to. All right. So the questions keep trickling in, but I also noticed that we're slowly starting to be out of time here. So I will suggest we do one more, and then we'll call it a day here. And folks, if we don't get to your question, you can always come back to us in the community and ask there. We will do our best to answer everything also after the session. Just looking for, here it is. So here is a question from Deepak. How frequently would Fleet Manager connect to Git? Is that pull timer configurable? And how frequently would a downstream cluster connect with Fleet control for changes? This may be important when you have thousands of downstream clusters connected to Fleet on edge use cases.
Yeah, that's an excellent question. So if I remember correctly, I think it is currently set to, let me not lie to you, I was about to say 10 seconds, but I may actually be mixing that up with another GitOps tool. But what's more important there is it is configurable. It polls based on a specific time, but that's something that you can also change. And essentially, it's the Fleet controller that's doing that main communicating with the Fleet agent, and also keeping an eye on the Git repo custom resource definition to check that out. So that is configurable, and that's a really awesome thing, because just to your question as well, is you might have applications that rarely undergo certain changes, but that kind of becomes a cost over time, if you're going to be polling every, for example, every 10 seconds on an application that changes perhaps, every couple of weeks. So it's a great thing that that's something that is configurable. And again, like Tim said as well, we might not get into all the nitty-gritties here, but let's carry the conversation over to the SUSE and Rancher Community Network. And I'd be happy to also share with you some of the documentation. And if you want to carry out some of those examples, we can also do it over there, but it is configurable.
All right. I would suggest we call it a day here. There are a few minor questions that we still have here, but please, folks, send them over in the community. And if you aren't a member of the community yet, you can find the green button at the bottom of your screen that gets you over there.
Absolutely.
All right. So any final words?
Yes. Firstly, just thanks again, everyone, for actually tuning in. For those of you that have been a part of most of the journey for Cloud Native at Scale, I really appreciate you guys sticking with us throughout the particular journey. Once again, please remember that it is all of these sessions are available for you to watch on Crowdcast. Some of them are available on YouTube in that specific Cloud Native at Scale playlist. So if you need help with accessing in any of those resources, please reach out to Tim or myself. We'd be more than happy to help you in that regard. Please provide feedback to the polls. And I think there's one last poll that's going to be released. And it's just basically us finding out whether or not you found this session helpful. Don't leave it to the polls. Please provide your feedback as well inside the SUSE and Rancher Community Network. What were your favorite sessions? What sessions did you enjoy? Which ones did you least enjoy? And what were the reasons for that as well? Because all of that feedback is very useful for us. Please, let's carry the conversation over into the SUSE and Rancher Community Network, and we can continue to collaborate over there. I saw a lot of exciting questions in this particular session, and it would be great for us to carry those over as well. So from myself to all of you, goodbye.